So today's lesson is 11-1, which is connect ratios, proportions, and percents. So the first thing we're going to do is we're going to watch a video. It's called Solving Percent Problems, and it is in Khan, and it will be available for you after school, so you can watch it on your own for extra credit. So for the vocabulary, it says ratios and proportions. An equation in which two ratios are set as equal is a proportion. An equation in which two ratios are set as equal is a proportion. Now, again, we can solve ratio problems by writing our what number is question and then setting up a proportion and cross-multiplying or using equivalent ratios. Or, what we're going to learn today, we're going to practice a little bit today, is we can write an equation to solve. So, for example 1a, we want to solve real-world problems involving proportions. Now, it says, in a school, the ratio of faculty to students is 1 to 9. The school has 52 faculty, and we want to know how many students are in the school. Now, here, you guys, we're not going to write an equation. We're not going to write out what number is question. We're going to use ratios, okay? So the ratio that you see here is what? 1 to 9. So 1 to 9, what does the 1 represent and what does the 9 represent?
1 is faculty and 1 is students.
Right, so this is faculty to students. Now the school has 52 faculty. And we want to know how many students are in the school. So, first thing we're going to do is we're going to write down what we're comparing. We're comparing faculty to students. So the first ratio there is 1 to 9. So we're going to write 1 to 9. Now this is equal to another ratio, and it has to be faculty to students on this side too. So the problem tells us that we have 52 faculty. Where's that 52 going to go? On the top. Very good. So we've got 52 up here, and we're going to solve for how many students are in the school. Now, this one you can solve by cross-multiplying, or you can solve by equivalent ratios. So you guys, you have to look at it so that you can decide which is the most efficient way to solve this. You can cross-multiply, that's fine. It's more work, but can't you just multiply, say, what can I multiply 1 times to get 52?
52.
Yeah, you're going to multiply times 52. And so that means you can multiply down here times 52, and we get, let's see, 9 times 52, and that gives us 468. So X is equal to 468 what? Students. This is students at the school. Is everybody clear?
Mm-hmm.
And again, it is okay to cross-multiply. It's just a little more work that you don't really have to do. Okay? I would like for you to do this one with your table partners. It says, in a certain region, the ratio of female to male African elephants is nearly 3 to 1. A herd has 19 male African elephants, and we want to know how many female elephants are in the herd. So go ahead and take 2 minutes to work on this one. All right, so here is our important information. So in a certain region, the ratio is female to male. So this is 3 to 1 is female 3, male 1. Okay? A herd has 19 male elephants. So if I'm doing female to male, that 19 goes where? In the numerator or the denominator? The denominator. Very good. Okay. So here, this is my original ratio, 3 to 1. And we're solving for the female. Male goes 19 goes on bottom. So here, I also used equivalent ratios to solve this one. So I went from 1 to 19 and multiplied times 19. So if I multiply times 19 on the bottom, I have to do the same thing in the top, in the numerator. So 3 times 19, x is equal to 57 females in the herd. Example 2a is use proportional reasoning to find a percent. It says a recent study showed that 65% of college students use their campus as campus library regularly. At a college of 15,000 students, how many college students use their campus regularly? Now, on this one, you guys, we are going to write a what number question and then set up our proportion. Or actually, I would like to use the equation for this one, okay? So, what is important here? 65% of the college students use the library regularly, okay? What else is important here?
15,000 students.
Right. So the college has 15,000 students. And what are we looking for?
How many college students use their campus library regularly?
Right. How many use the library regularly? Now, knowing that information, what is our what number question? So we're going to write what number is 65% of 15,000. Okay? So, for this one, you guys, we're going to write an equation. So we're just going to translate this English question to math. Okay? So here, if I don't know what the number is, what am I going to use? X. We're going to use a variable. Very good. So there's my X. We've got is in math. What does is in math mean? No. Of means multiply. What does is mean? So, the is means equals. Now, this is 65%. Percent means per 100, right? So if this was 65 per 100, how do I read that? 65 hundredths, right? So we're going to write 0.65 for this. 0.65 for my percent. Okay? Also, you could see that you could just change this percent to a decimal just by doing the loop, right? And then what does of in math mean? Right. Of in math means multiply. And what are we multiplying by? 15,000. Now, you guys know how I feel about putting too many dots on my paper, right? And we don't use x for multiplication, right? Because we have a variable x here. So we're going to use parentheses. So times 15,000. And then all we got to do is simplify. So 0.65, 65 hundredths, times 15,000 gives you what? So 9,750 x is equal to 9,750 what? Students who do what?
Use the library regularly.
Very good. Let's write that down. So 9,750 students use the library. Is everybody clear? Did everybody understand how we just translated this question to math? And then we simplified it. All right, example 2b, you're going to work on with your table partners. It says, in a school of 256 students, 5 out of every 8 students regularly buy hot lunches in the cafeteria. How many students regularly buy hot lunches? Now, I'm going to give you a heads up. Again, this one is one that you need to use proportions to solve. Okay? All right, so it says there are 256 students at the school. That's important for us to highlight. 5 out of every 8 students regularly buy hot lunches. So the 5 is the people who buy hot lunches, and 8 represents the total. Is everybody clear with that? So I put hot lunches to total. That's 5 to 8. And then over here, we have 256 total students, so that's the whole, or the base, right? And then we're going to solve for the part that buy hot lunches. So here, I cross-multiplied, okay, cross-multiplied, and then I got 160 students. So, you could have also just multiplied to get from 8 to 256. You could have multiplied times 32, right? So, you could have multiplied times 32 here, and then multiplied times 32 there. Is everybody clear? Mm-hmm. All right. All right, so for example 3, it says a community swimming pool has 1,250 members. This quarter, 6% of the members have signed up for swimming lessons, and 62 members have signed up for diving lessons. How do the number of members taking swimming lessons compare to the number of members taking diving lessons? All right, so you can see that we need to compare something, right? It says, how do the number of members taking swimming lessons compare to the number taking diving lessons, right? So if I'm comparing something, of course, that means that we're going to use less than, greater than, or equal to. Is everybody clear with that? Mm-hmm. Okay. Now, what else is important here that I should highlight?
There's 1,250 members.
Yep, there's 1,000. The pool has 1,250 members. That's a total, right? What else do I know? Yes? So 6% of the members signed up for swimming lessons. And then finally, what else do we know?
62 members.
Right. So 62 members signed up for diving lessons. Okay? So obviously we don't have to do any calculations for the diving, right? Now, for the swimming lessons, what could your what number question be? All right. So my what number question could be, what number is 6% of 1,250? Okay? Now, because we have this what number question, let's go ahead and use our equation. Okay? So, there's my what, so that's going to be that's going to be the x. Very good, that's our variable. Here's is. What does is in math mean? Equals. What do I do to this percent before I put it into my equation? Change it to a decimal. Very good. So we can bloop, bloop, and this becomes 0.06. Everybody good so far? What does of in math mean? And what are we multiplying by?
1,250.
Very good. So we're going to multiply times 1,250. So x now, let's put in our calculator, 0.6 times 1,250, and that's going to give me 75. So x is equal to 75 to what? Yes, this is for swimming lessons. So signed up for swimming. Is everybody clear? All right. Now we have to compare. What are we comparing to?
62 members.
Right, 62 for diving. So here we're just going to write, this is going to be swimming lessons compared to diving lessons. Let's put L. Swimming lessons to diving lessons. So this one is 75, this one is 62, and of course, what symbol do I put in there? Greater than. So, how do I say that in a sentence? So to answer our final question, we just write that more members signed up for swimming lessons. Now you guys are going to do this next one with your table partners. It says Kelvin reported that 3 out of every 8 students were wearing red for School Spirit Day. If there were 296 students in the middle school, how many students were wearing red? And what percent of the students were wearing red? All right, so the important information here is that 3 out of every 8 students were wearing red. So that's red to total. Is everybody clear with that? That's red to total. Now, it says there are 296 students at the school. So is that going to go in the top or the bottom? That's going to go in the bottom. So 3 out of 8, there's 3 out of 8. And here is the rest of the proportion. And of course, we're using cross multiplication to solve it. So here, we cross multiplied. We got 111 students are wearing red. Is everybody clear with that? So 111 students are wearing red. Now we want to change that to a percent. Okay? So I took the 111 students and I put that over the total number of students and changed that to a decimal. So when I change that to a decimal, I get 0.375. And of course, to change a decimal to a percent, we just to the right, and we get 37.5%.